Module 5, Part 1 is simplifying rational expressions. In this objective, so for objective 1 in this module, I want you to simplify rational expressions by factoring. And I've broken up this process into two parts. Part 1 is your goal is going to take a rational expression from expanded form to factored form. And so in order to do that, the goals that you need to consider is to be able to determine what strategy to use to factor either the numerator, denominator, or both. So call upon previous knowledge of factoring quadratics. And then in the next video, I'm going to take you through part 2, which is finding the excluded values of the rational expression and then write it in standard form. But in order to do part 2, you have to be able to do part 1, take it from expanded form to factored form. And so you need to be able to factor quadratics. And so that's why I broke it up into parts. You need to master part 1 before you can move on to part 2. So let's venture to part 1. And again, this objective, simplifying rational expressions by factoring, before I can even get into this, I have to discuss quickly what a rational expression is. Rational expressions, the term rational, just means that it is a fraction. So I'm going to take a couple notes. Rational, meaning it's fraction form. Meaning there exists a numerator over a denominator. So I've given you an example right here. The expanded form, I'm going to call it, is in a fraction, right? There's a numerator. The numerator is here, x squared minus 81, and it sits over the top of the denominator, x squared minus 8x minus 9. Both are quadratic expressions, but it is a rational expression because it exists as a numerator and a denominator like that. That's what makes something a rational expression. Before this module, in modules 2 and 3, we've only been working with quadratic expressions, meaning only either the top or the bottom, something like that. But just consider that's what makes it rational, because it has a numerator and a denominator. So, again, in this video, this part 1 of this objective is you're going to take a rational expression from expanded form here, something like that, to factored form here. So expanded form, I've given you an example. X squared minus 81 over x squared minus 8x minus 9. Your goal by the end of this video is to be able to take it to factored form, so something that looks like this. X minus 9 times x plus 9 over x minus 9 times x plus 1. So please reference this example that I've drawn up for you as you're working through these problems, because it'll help you check your work as you go. If you factor it and it looks something like my factored form here, then chances are you're on the right track. So again, by the end of this video, you should be able to take it from part 1 here, expanded form, to factored form here. So let's go about doing that. I'm going to show you exactly how I would do this. So let's look at number 1. The first step I need to do, and I wrote it here, is decide if the numerator, denominator, or both need to be factored. And then if they do, decide what strategy to use. These strategies should look familiar. They're from Module 3, Factoring by Solving, Quadratics. So the first one is finding the GCF, greatest common factor. The second one is finding the MACAB T-chart. And third is the difference of squares. So I need to look at the numerator first in number 1. And if I analyze the numerator, I know that a MACAB T-chart has to be ax squared plus bx plus c. It needs all three of those terms, and a has to equal 1. In this case, the numerator right here doesn't fit that criteria, so I can't factor it with MACAB T-chart. Difference of squares, it has to be something like x squared minus 49, where 49 is a perfect square and it's missing its b term. In this case, it has the b term, it does not have the a term. And so the difference of squares doesn't work either. So the only thing left to do is consider the greatest common factor. And so I'm going to break down my factoring into parts, so please show your work exactly like I'm showing it. I'm going to work with the numerator first. In this case, the numerator is 3n plus 27. And I decided that it could potentially be factored, and it can potentially be factored by taking the greatest common factor. Now, I know my factors pretty well, and so I would consider the numbers 3 and 27 and decide on my greatest common factor between that. If you don't know them very well, then you need to show this work. Right here, I'll put it in blue, the factor tree. 3 and 27. 3 is already a prime number, it doesn't break down anymore, but 27 breaks down into 9 and 3. I can break down 9 again if I want into 3 and 3. But I see automatically that the only number in common, the biggest number in common between the numbers is 3. So I know that my GCF is 3 for the numerator. So I can write that, 3, and I know that in parentheses is going to be what remains after I factor out the GCF. I know again that there is no n in my GCF. 3n has an n here, but 27 does not have an n, so I know that n doesn't exist in the GCF. Now, to factor it out of both terms, I need to take the first term, and again, please don't ask me questions unless you show this side math. So the first term divided by my GCF, that equals 3 divided by 3 is 1, or they cancel out, so I'm just left with n. Then my second term divided by the GCF. In this case, 27 divided by 3 is 9. Positive 9, so I put plus 9. That is my numerator. All right? Consider that. Hold on to that because I'm going to reference that again in just a little bit. Now let's move on to the denominator. I'll show my work here for the denominator and try to separate it as best as possible. The denominator is 6n squared plus 54n. Now it's the same process. If I analyze that expression in the denominator, I have to go back up here to my 3 different choices: GCF, MATLAB, T-chart, difference of squares. In this case, again, MATLAB T-chart wouldn't work because I don't have all 3 terms. Difference of squares wouldn't work because in order for difference of squares to work, you can't have a b term. In this case, I do have a b term, the 54n. So the only thing I can do is GCF. And something that jumps out at me initially is that they both have an n. So that's another clue I can think of to think, I could probably factor this by taking the greatest common factor, because at least they have an n in common. So I need to find the GCF of the numbers. So I'll do 6 and 54. 6 breaks down into 3 and 2. 54 breaks down into, let's see, 9 and 6. You could use different numbers, but you would arrive at the same answer. In this case, the biggest number I see in common, I could break these down further if I wanted to. 3 and 2. But the biggest number I see in common is the 6. So I know that the number 6 is going to be part of my GCF down here. And then let's look at the n's. There's 2 here and 1 here. Remember, I always take the lowest powered n for my GCF. So 6n is my GCF. Now I need to factor out the GCF from each term. So I take the first term. Please show your side math. 6n squared divided by my GCF of 6n. 6 divided by 6 cancels out. There's 2 n's on top because of n squared, so one of them cancels out, and I'm left with just an n for the first term. Now, the second term, 54, n divided by my GCF of 6n. 54 divided by 6 is a positive 9. And then n divided by n, they cancel out, so I'm just left with plus 9. This is my denominator. So to end this video and to end the part 1, be able to take a rational expression from expanded form to factored form, I write it now in factored form. Let me make note, this up here is expanded form. I'm going to write it now in factored form with my new numerator and my new denominator. So factored form, I'll put right here. the numerator, remember we're going to reference, this was the numerator in factored form. So it's 3 times n plus 9 over my denominator in factored form, which is 6n times n plus 9. That is factored form. So you need to be able to get to that step, and that is part 1, taking it from expanded form to factored form. You need to be able to get to that step before you can move on to part 2, checking for excluded values and simplifying or canceling out like factors. And so go ahead and try. I know I didn't leave you enough room, or a lot of room for number 2. If you need to show your work on a separate sheet of paper, that's fine. But try part 1 on numbers 2 and 3. So this should say try numbers 2 and 3, part 1. And then raise your hand when you are done so that I can come check your work. At that time, then, you can move on to part 2's video, finding the excluded values and canceling out like factors. Because again, to end this process, we just did we just went from step 1 to step 2. Step 1 to step 2 took it to factored form. We still have to do part 3 and part 4. This is the end goal right here, to get it to something to look like this. It went from here, expanded form, to simplified form, and stating the excluded values. My final answer should look something like this with the excluded values. So in the next video, you're going to learn how to find excluded values and then cancel out like terms.